Everyone, John here, senior software engineer with 10 years of experience. I'm the lead maintainer of Latterly.io, which is an open source educational platform and social community that can help you learn to code and land your first or next programming role. Today we're doing some LeetCode. Let me share my screen. We are going to implement a prefix tree, also called a trie. Here's NeetCode. We love NeetCode. And we're just going to scan through the video before attempting the problem. No, we're not. I'm going to go to the problem, time box it to 10 minutes, and then come back to the video if needed. But one thing I do like about this video is that it's relatively short, 20 minutes. 20 minutes at regular speed, and you can crank these videos up to 1.5x, and you can still listen fairly well. All right, so we'll go over to LeetCode. And search for TRIE, that's a trie. Implement trie prefix tree. Oh, there's a second version, interesting. Frequency is like 0 on it though. And you can see tries do come up. Tries do come up, got a 45% frequency on this one. One thing I don't like here, it's forcing us to do the object-oriented approach. So you can do a trie with Python dictionaries. I think it's going to be much simpler. And if I do add the trie to the Latterly LeetCode kata, I will be asking people to do both forms. That helps us learn the abstract pattern. When you understand two concrete patterns, if I can implement a trie in the object-oriented pattern, and I can implement a trie in a pure Python dictionary or a JavaScript object, these different primitives, but the same abstract pattern, then I know I'm actually learning the concept and the pattern rather than just memorizing keystrokes, right? Okay, anyway, let's do it their way, because if you get asked a problem in an interview, you better give them the answer they're looking for, right? So the problem reads, number 208. A trie or prefix tree is a data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. Implement the trie class so that trie will initialize a trie object. We will have a void method, an insert void, which inserts the string word into the trie. And then a Boolean called search, which returns true if the word is in the trie, and false otherwise. And then we'll have another Boolean method called starts with. That's going to return true if there's a previously inserted string word that has the prefix called prefix, and false otherwise. Yeah, so there's going to be built-ins for these, like JavaScript has includes. Python also has includes, right? JavaScript also has find.find. Here you could do a regex starts with. That would be pretty intuitive. So yeah, you can totally implement these without a trie, without doing a trie. A trie is going to be a nested tree, basically. If I didn't know what a trie, I'm talking through sort of like brute force or naive ways to implement these if I didn't know what a trie was. I might reach for regex, I might reach for the includes method. And so really the only one, surprisingly, the only one that I would be at a loss for if I didn't know what a trie was and I was trying to solve this problem, the only one that I would be failing to solve is being able to insert into the trie as an internal store. You'd be like, what does that even mean? I don't know. Maybe you would store like a list. If you knew, hey, I just need some data structure that contains a bunch of words, maybe you would store a list. But the right mental model here, where we can quickly determine prefix, and this is why it's called a prefix tree, is it's going to be a nested tree or a nested dictionary. And so if I have 5 words, maybe learn, learned, learning, we have these English conjugations. L-E-A-R-N is shared among them. And then let's say I have like a really, really big list and it's not sorted. And so I could look up L-E-A-R-N and immediately see that there's like these three options more efficiently than sorting the list, which would be n log n, right? Okay, I think that's the lesson we're supposed to be learning. So how am I going to implement this? I'm going to be using a dictionary as an internal data structure. So here, I'll call this prefixes. I want to put it out there, but I don't know if I can do that. I think so. Let's just log. Let's just log that I can reach prefixes. Yeah, so I got access to prefixes this way. Okay, so what do I want to do now that I have it? Well, we want to insert. We want to insert. So I can do a counter. I need to go through every letter of the word. I just do for char and word. Prefixes, I'll call this curdict. And we'll start with self.prefixes. So we're going to refer to this dictionary and just traverse it, basically. And I'm going to say, hey, every letter that I dive in is a nested dictionary, and I just want to make sure every letter is there. That's all I'm going to do. And then on the last letter, I just won't give it a child dictionary. And that's basically how you know that that's the end. You can do this all with pointers. So I could have like a dot next or children. So children might need to be, we'll see what leetcode wants me to implement here. But instead of doing like a global prefixes, I might just do like my own children. Maybe that's the right thing to do. So for every character in the word, we want to make sure that the child dictionary exists. Oh, so I do need the position because I need to know if it's the last one. I can put a dictionary on every, we can still do it. I can just put a dictionary on every child, and then if the length of the keys of that dictionary is 0, that's how I know it's an end node. Okay. So curdict, yeah, we'll use if-in. If char and curdict, so if we already have that dictionary, and then we'll dive, else we need to create that dictionary. We'll create it just like that. Curdict char, the char index of curdict is, now we've created that nested dictionary. And then either I traverse to the lower level or I create the lower level. In either case, I'm now updating curdict. So you can call this diving. This is like a depth. It's kind of like akin to a depth first search. You're stepping down a level. These are some of the ways we explain that. Stepping in, stepping down. Cool. And so here I'm guaranteed to have the dictionary char child. Good. All right. In this case, I can really just continue. I can just continue because it's going to get assigned here. So we know that the character exists here. And so really I can write this if it's not in. And there's really only the one condition to deal with. Okay, I think we have insertion. So let's see, this test case is going to try to insert. So let's see if we can get Apple in here. So let me print at the end of this method, it's going to call Apple. And then let's see, I should see the nested word Apple. Yeah, there you go. So that's a try, basically, A-P-P-L-L-E. You see how they're nested? That really is what a try is. All sorts of complicated explanations, but that's it. This is the dictionary, Python dictionary representation of a try. It's not a try class, which LeetCode wants us to build. So it wants the object-oriented answer. So we'll continue to do that. So you can have a try representation in different forms, but this is a dictionary try. Okay. What to do next? We need to go do search. Cool. So we'll do a similar logic here on search. We'll get a reference to self.prefixes, and we will navigate through the word given. And what do we want to do? If I run into a missing condition, I'll return false. And if I never run into a missing condition, I think I can return true down here. Let's try that out. Okay, so let's say I'm given Apple. I previously inserted Apple, and now I want to search Apple. That's actually the test case. Great. So we'll just be able to run the test case. And so I have an A. If it's not in there, I'm creating it. This is not what we want to do. Instead, if it's not in there, I want to return false. If it's not in there, I want to return false. And if it is in there, we will step in. So I step into my A. Eventually here, I'm going to get a key error. So I could wrap this in a try and then handle the error, and in the error case, return false. The other thing I can do is I can say .get in Python. That will never throw a key error. If a key value pair is missing inside of a dictionary, get will return a default value here. And if you don't specify the default, then it's implicitly a none. It's implicitly a none. So this syntax on line 20 will allocate a null reference to current dict if that key is missing. And so what I can do here is I can just say if there's not a dictionary. So I can say if there is not a dictionary, or, I mean, a more explicit way to do this. Let's do this even more explicitly. I'll say is none. If curdict is none. And we want to do that first before we try to compare with, before we try to use the in operator, because you're never going to have anything in a none, right? It's null. Okay, so we get this dictionary pointer. Yeah, this should work. All right, so let's see if I get this second step right. So we're going to get try, insert, search. I'm expecting it to look good this far. Really, the app check should also look good. Okay, so my output is null, null, true, true. And what's the expected? Null, null, true, false. Null, that's good. Null, that's good. True, that's good. And if I search app, it wants a false. Let me read the instruction. Maybe I missed something here. So search returns true if the string is in the try. Okay, I was doing the starts with thing. So this logic actually goes over here into the starts with thing. Because app, it starts with that, but I need to detect whether I'm at an end node or not. Now, I would say I have the word app in my try, so it's strange. In inserts the string into the try, returns true if the string is in the try, was inserted before, and false otherwise. Okay. Yeah, it's strange to me that it wants me to say that app is not in the try in the substring case. Because if you think about the applications of a try, like autocomplete and whatever, maybe spell checker. Generally, the substring match is like, it's there. You consider it there. So it wants to do an exact match, which is just like, you usually wouldn't use a try for an exact match. But that's okay. So we just need to mark this as the end node. Previously, I talked about you can use the child keys are 0 as an end node marker. That's not going to really work in some edge cases. So I can determine that app is an end node if it was inserted first. But then if apple gets inserted later, now the original app has child key. So that strategy fails to say that this was inserted literally. The obvious thing to me to do is have an auxiliary map. We could have like literals. This is taking a global approach again. Another way to do this is end node. And then you would handle this here. This would be like the more OO way to do it. This is probably what they want me to do. This is the more OO way to do it. So in this case, I should not be creating little object children. I should be creating little try children. All right, fine. Yeah, both of these will work. And the time complexity, I think, is equivalent anyway, because looking up a literal in a map is O of 1, and checking whether it's an end node is going to be O of 1. So I think that from a complexity standpoint, they are equivalent. But in terms of like the proper OOP code structure, this literals map is too global in style. It's like not preferred. It's not preferred. It sort of mixes the scoping concern. So probably your LeetCode interviewer doesn't care that much. Like they just want to know if you can answer the question. So I don't know if anyone cares, but like the more OO thing to do would be to have a local variable instead of this global representation. Okay, so if I'm going to do it this way, I think I still need a prefixes dictionary. Or can this be a try? It would be like children. It would be children, and it would be a dictionary of tries. Is that right? I think that is right. Let's try this. Let's see if this works. So you're going to have a dictionary that maps strings to try. Okay. So self children is going to be an empty dictionary. I don't even need to do that. I can still just do this, I think. I'll default that to false. So we'll default that to false, and then we can override it if it is indeed the end node. And now I need to have a counter here. How do I know if I'm in if I am the last letter? I think I need to have a counter here. So instead of for char in word, I will do for I in range len word. I hate this so much. I definitely prefer just using a dictionary to making this follow the OOP pattern. It's more verbose. It introduces technical complexity that's just totally extraneous. All you're doing is introducing a buffer layer around the dictionary. That's okay. They asked for it, so we give them what they asked for, right? So char is going to be the I index of word. And we can kind of use this block still. But here, I'm going to say it's going to be a new try. And so if the character is not in the current dict, this is going to be children now. And this is why it's important to practice, because doing refactoring in the middle of your interview will kill you. I would say if you're in the middle, like if you're in an interview and you've gotten as far as I did, and then you face the decision to keep using dictionaries or convert to a purist OOP with the try and is end node, don't go purist. Do not refactor in the middle of your interview. I'm only doing that now because, like, in theory, I'm not under time pressure, but also in theory, I should be doing these kata as if it was a real interview. So I'm kind of breaking my own rule. So yeah, I would really like to finish this out using nested dictionaries, except that I'm pretty sure leetcode is going to tell me that's not what it wants. So whatever, we'll get there. So I know if I'm an end node, I'm told explicitly here is end node. Equals, and what's it going to equal? I is the length of word minus 1. So like dad is DAD, but that would be index 2, right? DAD. So minus 1. So is it rangelen word minus 1? I think so. No, I don't think. I think the range keyword does the 1 to 0 shift for you. Okay. I don't like that this is showing up in white text. I expect that to be colored. So let's see if this works. So do I expect this to work? So I get like A, right? It's not in there. Let's make a try. That's not going to be the end node, P, P, L, E. I expect this to insert properly. So let's log that out. Try is not defined. Yeah. This is like a Python thing. Like you shouldn't refer to a class when you're inside of itself. I hate OOP so much. So I could do like a try node class and then like a try container class. So I'm going to roll this back and do this the hacky way, and then LeetCode is just going to tell me I'm wrong, and then I'll be curious to see how LeetCode wants me to do this. I could do like some type let's see if I just do this, if that helps. I could do some type annotation stuff. Missing a positional argument. Where is this? That's in the test harness. This is not defined. So I have A, P, P, L, E, yeah. Okay, so I get my nested tries. This is like, refer earlier in the video when I logged the dictionary and how much easier it was to read. This is awful to me. So yeah, I will definitely encourage you to do dictionaries wherever possible. Frankly, if my interviewer asked for a try class, I would propose that they let me use a dictionary. I think a lot of them will say, yeah, that's fine. Okay. No. Let's get the search. Let's see if the search works, and then I'll go look up the solution. So in this approach, when I'm using the objects, we're going to go through self.children. And we're going to say for every character in the word, if the current dictionary is none, really this should be called like cur try. Now that we've changed it, that's fine. Or if it's not in there, we will return false. But if it is in there, we'll step in. Now we need to know that the literal was inserted. And so this was my hacky bit. No, we'll use the endnode thing. That's what this was supposed to do. And what I want to say is that once it's been set to true, it's always true. So I want to say or once has been set to true, make it permanent. And this solves the problem about, hey, what if I like the insertion order on app versus Apple? That's what this logic does. Art with Brenda, how are you doing? How's it going, Art with Brenda? CJ, what language? Answer is Python. You can see it right up there. Thank you for the follow. Throw some likes on the video if it's interesting you. Okay, let's go down here to search. So now that I have navigated through, I also want to know here if I am at my last letter. So we'll do this pattern instead of for character in word. We'll do the for I in range, get the current letter. And then if it's the terminal node, do you have a YouTube channel? Yes, I do. Link is in the bio. Today's stream will be saved to YouTube, by the way. So if you are a late joiner, you can look it up there. Okay, and so this will be cur_dict at this point in time. So we loop through the letters of word. We loop through the letters of word, and we have this reference right here. I can indent this, by the way. Yeah, I'm still in the loop. That's okay. So here, if it is the end node, really in Python, I could just assert. Let's see. What's the quote unquote right thing to do? We want to return true or false. So if it's not an end node, then we return false. And so this should help us get to that false condition in this test case when we insert search search and the second search is looking for app. And our search implementation should not find a substring app, which would be like your JavaScript find. That's not what this problem wants. This problem wants to know that the literal was inserted, the entire string, not the substring. And so in that case, we should be returning false. That's why it's expected true, then false. All right, let's see. Try object has no attribute is in node. Well, the try does. The try does have we can just wrap in an if, that's fine. I don't know if I can do this. I think I might need to use the Python dunder. So yeah, this is one of those things where we get to be clever. This is not cool. Doing clever logic is not cool. But what we can do is we can take advantage of the fact that if it is true, it must be defined. So I can say, if it is true, or if it's not true. Let's see. This will still give me an attribute error, won't it? Yeah. Okay, let's see if I can do this if is in node in self. Let's see if I can do that. And here I want to say if it's not in self, because if it is in self, it must have already been set to true. So we'll just keep it. Is this correct? I don't think that's correct. That's not correct. So if it's there, then we will conditionally use it. And if it's not there, then we will just set it from the local value. The try is not iterable. Yeah. So I need to check my dunder. This is awful. In search. If cur_dict is not. What problem are you doing? Mini Cheddar's bag. We're doing 208 implement try. Thanks for the follow. Where are you from? I'm over near DC. How about you? Did you mean dir? Yes, I did. Argument of the type built-in function is not iterable. Okay, cool. We need to call it. Yeah, I hate that so much, dude. Let's see what happened here. So null, null, false. False came when I tried to search Apple. Let's print that value. Right. So dir is not the right one. Is it going to be keys? Let's see. Has no attribute keys. There's a way to access the internal dictionary, but I guess that's not dir. New repr hash get attribute. Oh, I can do get attribute. Yeah, let me try get attribute. So if I want to get the attribute by the key, yeah, I'll need the char this way, I think. Children by char. Dict has no attribute A. Thanks for the follow. Why does it look like Python? Because it is Python. Yeah, so here we're checking the, this is so silly, right? So the class has an internal dictionary representation. Let's see. What's the internal dict dunder? I thought I tried this earlier, and it said that dict was not a thing. Do I need to define dict? Is that the issue? Has no attribute dict. Dict object has no attribute dict. Because when I point to children, I'm pointing to a dictionary. So the children is, yeah, the children is a dictionary. It's only the value of the children that's the try. Argument of type try is not iterable. So it is a dictionary, and then it becomes a try, right? That seems to be the problem. Yeah. All right, I could add logic, which is like, if you're a dictionary, do this. If you're a try, do that. I would really prefer not to. Let's look up the solution at this point. Yo, man, you're a pro at this. I spent 6 hours on a coding assignment. Thanks. Yeah, I'm not feeling like a pro right now. Maybe if I don't have to do it OOP, I could feel like a pro. Don't look up the solution. Why? You're making progress. Yeah, but it was in the wrong direction. So this is a Java try. It's all Java because it's OOP. I'm a big fan of time boxing because you want to maximize the time of your overall learning cycle and job search, right? So time boxing is super helpful. Is there not even a Python solution over here? Yeah, okay. They did a try node, try container. I really don't like this. I really don't like this. So a try is supposed to be a recursive data structure. So if you have to separately type the container from the internal node, you've broken the recursive nature of the data structure. Yeah. So Leet is like code grade. I don't know. Let's take a look at code grade. Maybe it feels like code grade is like the school version of leetcode. They seem somewhat similar. Yeah. Hey, quick question. I need to get a job. How can I learn to become a Python developer? Get a trusted bootcamp. So go to coursereport.com, browse schools, go to all schools, sort by most reviewed. A high quality bootcamp will have a score of 4.25 or higher with a minimum of 400 reviews. And then it's going to depend what country you're in, but like Lewagen is pretty good internationally. They're not in US. And so you can just scroll through here and try to find an education provider that does Python. So Springboard's pretty good in the US. I'm not sure if they have Python. Let's take a look. So for the data analytics career track, data science career track, they do Python. Does not look like covering everything from Python to SQL and the latest frameworks. So they even touch on Python in the software engineering track. So there you go. I'm from Brazil. Cool. Let's see. Is Lewagen in Brazil? Rio de Janeiro, is it Brazil? Yeah. Man, I want to visit. That would be fun. That would be a lot of fun. So yeah, maybe you can look into Lewagen. I've had many friends ask me this. Do boot camps actually work? I went to uni to be SWE, but maybe. The average boot camp is not good. Do not pick a random boot camp. Do not pick the average boot camp. Do not believe the idea that, quote, boot camps work in general. Stereotyping boot camps is a terrible move. It's a terrible move. You need to find a high prestige boot camp in particular using the technical rule that I just laid out for you. So I'll show you the academic paper. So hireability and educational prestige, you can find this on SSRN. Okay. This is the paper where my research demonstrates the rule for a prestigious boot camp. You do not want a random boot camp. You want a prestigious boot camp, a high quality boot camp. Opinion on Bloom Tech. I don't know. I don't know what it is, but let's go check it out. Bloom Tech. Is it the same as Bloom Institute of Technology? Is this Bloom Tech? It does not meet the prestige rule. So the rating is 428, which barely makes the 425. But the reviews are not enough. The reviews are not enough. So I think there are better schools. There are definitely worse schools. There's definitely worse schools as well. They also don't have a job guarantee. What courses do they have? Backend, data science, full stack. Okay, at least they got full stack. They're doing React and full stack. That's good. Look, whoa. And then the cost is like double what it should be, right? Look, I think there's a much worse boot camps, but I think there's also better boot camps. So I would not recommend this. I would not recommend this school. Yes, it's a trap. Well, I don't know if I'd call it a trap. I would just call it maybe a bad investment, like more expensive than necessary, right? Look, if it was the only boot camp, maybe it would be a decent choice, but there's just much better choices out there, right? I don't like the idea, just because a boot camp is expensive, I don't like the idea of calling it a scam. I'm not into that. I'm not into that. I know some people do that, but I'm not into that. Okay. Did we look at the actual solution? I mean, this is someone's solution. I really don't like this solution. Let's look in the other solutions. A recursive dictionary solution. Absolutely. Terminal children, it's just a dictionary. Nice. Oh, they just used a Boolean. So the literals map that I used is not necessary. We can do the dictionary with the terminal thing. How does this work? Because they're still setting try. I graduated from boot camp and I've been searching for a job for a year now. How can I land an interview? You need to join Latterly. That's the reason that I created Latterly. So Latterly is an open source educational platform and social community. You can join the Discord for free. You can use the 24/7 AI chat support for free. You can book a call with me if you want to. And there's the standard checklist. All right, you need to log in, whatever. There's a standard checklist that walks you through step by step on how to get a role. Like, here's the checklist. So I'm not going to walk you through this all now, but it's very well defined. And the reason Latterly was created, it is not a boot camp. It is a boot camp alternative and supplement, because career services at the typical boot camp are awful. And so this checklist will help you overcome that problem using things like the networking scripts. I'll give you one example, the networking scripts. So you need to be networking, right? And then it's like, okay, I'm networking. How do I do it? What do I say? Well, that's why we have the networking scripts. So that's the solution to your problem. And then if you are having trouble applying this guidance, that's when you can get a one-on-one mentorship, and I'll walk you through it. But really, it's all there and it's open source. It's nicer to use a 26 length list instead of a dictionary. That's hilarious. That's a good joke right there. I don't know if y'all understood that joke, but that's a top tier joke. I'm about to wrap this up. This problem annoys me. Let's see. I've applied to 150 jobs and had one interview. That's pretty common. That's pretty common. That's pretty normal. If you are not doing social follow-up properly, if you're just applying online, one interview out of 150 applications is actually pretty normal. How many referrals did you have is going to be a much more important thing to ask. Based on the fact that you had one interview, I believe you got less than 20 referrals. One referral. Yeah. so did the referral lead to the interview? Or was the interview one of the ones that was not referral? Yeah. Okay. So your application to interview rate is 150 to 1, which looks bad. But your referral to interview rate is 1 to 1. It's like, thank you for proving the point. It's all about social networking. Okay. Yeah, you got to get those referrals. Absolutely. So basic recursion-based solution using a dictionary. Mini Cheddar says I wasn't joking. Oh, then okay. I don't know if you're double trolling me or what's going on, but using a 26 that's like a terrible. It's like a terrible. It's not a try at all, and it doesn't generalize. It's a hack to solve this one problem. Thank you. Very, very welcome. So this is so uncomfortable to me. It's like we're going to do OOP, but we're going to have this dictionary internal representation. That seems to be like the way, right? Like this is the way. So we'll insert it if word children get word 0. This looks weird to me. I don't know. I'll have to study it more. Thanks for joining the stream. I'm not even sure if this is a good solution. I actually like the idea of just having the external map, like this literals map. And then I can just use dictionaries instead of these mixing types. It's the mixing types that I feel like is really icky, basically. No, I mean, instead of children being a dict, it can be a list. Yeah, I understood you perfectly. Did you understand what I said? That doesn't generalize to tries. That is a hack that solves this one problem. You're not actually understanding how to use a try if you do that. I do have a Discord server. So Latterly, I keep typing the L and it's going to my LinkedIn. Latterly.io, link is in the bio. And under community, there's Discord right there. And you can join for free. All right, y'all, thanks for being